TALib, or the Technical Analysis Library, which is one of the most well-known libraries for technical analysis for financial instruments. I'll be covering briefly some high-level information about the C++ TALib, which was originally developed in C and C++, and then I'll move to the Python wrappers around the original TALib library, which are more useful in practice. The original TALib library encompasses around 200 indicators that are commonly used for analyzing financial instruments, such as ADX, MACDs, RSIs, stochastics, and Bollinger Bands, as well as candlestick patterns. The original TALib was released in 2001 and has been used ever since for more than 2 decades. On the TALib website, that is ta_lib.org, you can find a list with all of the functions that can be used to calculate technical indicators. As I mentioned earlier, in practice, you might want to use the alternative Python projects that wrap and enhance TALib. Those are TALib Python and Pandas TA. We'll cover both of them. TALib Python is essentially a more low-level wrapper around TALib, allowing you direct access to most of the functionality within the C++ version. Meanwhile, Pandas TA is a more complex technical analysis library that adds some additional high-level functionality. Let's start first with TALib Python. Information about this package can be found on the page of the GitHub repo, as well as at the GitHub IO address. TALib Python is a Python wrapper for TALib based on Cython instead of SWIG. The original Python bindings were using SWIG, which unfortunately are difficult. Similar to TALib, the function interface provides a lightweight wrapper of the exposed TALib indicators. Each function returns an output array and have default values for their parameters, unless specified as keyword arguments. Typically, these functions will have an initial loopback period, a required number of observations before an output is generated, set to none, that is, not a number. All of the following examples use the so-called function API. We can import NumPy and TALib packages, we create a close variable using NumPy random, we calculate a simple moving average of the close prices by using the SMA method from TALib and passing the close variable. If we wanted to calculate Bollinger Bands with triple exponential moving average, we can import from TALib the MA_type. Then on TALib we call the bbands method and we pass in the close NumPy array as the first parameter, and then for the MA type we pass the MA_type.tFree attribute. The output of this method will be 3 variables: the value of the upper band, the value of the middle band, and the value of the lower band. If we were to calculate the momentum of the close prices with a time period of 5, we can call the MOM method of TALib by passing the close price along with the parameter time period equals 5, and we'll receive the output. Now, if you're already familiar with using the function API, you should feel right at home using the abstract API in TALib. Every function takes the same input, passed as a dictionary of NumPy arrays. We once again import NumPy as NP. We define a dictionary of inputs for the open, high, low, and close prices, as well as a NumPy array for the volume. Functions can either be imported directly or instantiated by name. From TALib we import abstract, and then we access the SMA function and we save it in the SMA variable, or we can also use the function method on abstract to get the same SMA function. These are 2 different ways of importing the SMA function. From there, calling functions is basically the same as the function API. From TALib abstract, we can import all the functions. This will give us direct access to the SMA, the bbands, and the stock functions, which will allow us to calculate the SMA on close prices by default for a time period of 25. We can also pass the price parameter if we wanted to use the open price instead of the close price, which is the default. We can then see how we can use the Bollinger Bands and the stock indicator, which uses high, low, and close prices by default, but we can also pass the prices parameter if we wanted to use high, low, and open prices instead. If we wanted to get a list of all the supported indicators, we can show all the TA functions supported by TALib either as a list or as a dictionary sorted by group. For example, overlap studies or momentum indicators. And to do this, we can simply import TALib and then we can print TALib.get functions or TALib.get function groups. In terms of function groups, they include overlap studies, momentum indicators, volume indicators, volatility indicators, price transforms, cycle indicators, pattern recognition, statistic functions, math transform, and math operators. You can find all the list of these indicators on the Python TALib GitHub IO page. If you wanted to install talib Python, you can install it from PyPy with pip install talib, or if you have the sources, you can simply run the setup.py on your machine. Naturally, talib Python needs talib as a dependency. If you're using Mac, you can install it using brew install talib. And you can find instructions in the documentation for how to install it on Linux and also on Windows. Now let's talk about the advanced usage of the Abstract API. For more advanced use cases of talib, the Abstract API also offers much more flexibility. You can even subclass abstract.function and override set input arrays to customize the type of input data. Function accepts, for example, a pandas data frame. Details about every function can be accessed via the info property. For example, you can print function, then pass stock.info, and you'll obtain details about the stochastic indicator, which is part of the momentum indicators group. You can also use the help method and the str method. Other useful properties of function include function flags, input names, input arrays, parameters, loopback, output names, output flags, and outputs. Aside from calling function directly, functions maintain state and will remember their parameters or input arrays after they've been set. You can set parameters and recalculate with new input data using run. For example, we first set the parameters attribute of SMA to a dictionary containing time period 15. Then we execute the run method of SMA and pass the results to result1 and save the results in the result1 variable. We then execute again the run method, this time with the input arrays2 as input, and we save the output in the results2 variable. We can also set the input arrays and change the parameters by setting the input arrays attribute of SMA and then running SMA with time period 10 to obtain a moving average of time period 10, or we can simply pass 20 to SMA to obtain a moving average of period 20. The talib GitHub IO page also contains information about all the different groups of indicators, including overlap studies, momentum indicators, volume indicators, cycle indicators, price transform, volatility indicators, pattern recognition, chart patterns such as dojis and hammers, statistic functions such as Pearson correlation coefficient, linear regression, standard deviation and variance, math transforms such as vector trigonometric cosine, and finally math operators. Let's discuss about Pandas TA. This is the high-level Python wrapper around the talib library. It is an easy-to-use Python-free Pandas extension with over 130 technical analysis indicators. Pandas TA makes it easy to use the functionality from the original talib together with the Pandas package for data analysis that contain over 130 indicators and utility functions, as well as more than 60 candlestick patterns. Many commonly used indicators are included, such as the candle pattern, the simple moving average, the moving average convergence divergence, or the so-called MACD indicator, the whole exponential moving average, the Bollinger Bands, the unbalanced volume, the Arun and Arun oscillator, squeeze, and many others. Note that in order to use Pandas TA, you also need to install talib to get access to all the candlestick patterns. Otherwise, only the built-in candlestick patterns will be available. In terms of features, Pandas TA has over 130 indicators and utility functions, as well as up to 63 chart patterns. Indicators in Python are tightly correlated with the de facto talib library if they share common indicators. If talib is also installed, talib computations are enabled by default, but can be disabled per indicator by using the option talib equals false. For instance, to disable talib calculation for standard deviation, or stdev, you can simply call ta.stdev and pass the parameters data frame close column, length equals 30, and talib equals false. You can also include external custom indicators independent of the built-in Pandas TA indicators. Pandas TA can also be used together with the VectorBT portfolio backtesting library, and you can find an example Jupyter notebook within the GitHub repo of Pandas TA. One of the features that Pandas TA adds on top of the original Python talib is the so-called data frame strategy method, with which you can get access to multiprocessing when doing all the calculations to obtain the technical analysis indicators. Within Pandas TA, you can easily add prefixes or suffixes or even both to column names to be able to distinguish between different indicators. This is also useful for custom chain strategies. Within the Pandas TA GitHub repo, there are also example Jupyter notebooks on how to create custom strategies using the strategy class. You should also be aware of potential data leaks when using the DPO and Ichimoku indicators. You might need to set the look ahead option to false and read the details for these indicators in the documentation. In terms of installation, you can install the stable version of Pandas TA using pip install pandas_ta. You can also always install the latest version on GitHub by referencing the GitHub repo. Let's go through a quick start example for Pandas TA. We can import pandas as PD and then import pandas TA as TA. We first create an empty data frame and save it in the variable df. We can load some data from a CSV file about a particular stock using pandas read CSV, or if we have the yfinance package installed, we can simply call df.ta.ticker and then we pass the ticker for the stock we're interested in. In this case, AAPL for Apple. Certain indicators, such as VWAP, require the data frame index to be a datetime index. In this case, something that you can do is replace datetime with the appropriate column in your data frame. You can use the setIndex method of the data frame and simply pass pd.dataframeindex, then pass the data frame datetime column and inplace equal to true. To calculate returns and append to the data frame, we can simply use the df.ta.logReturn method as well as the df.ta.%return method, which accepts the cumulative parameter which we set to true and the append parameter which we set to true. We can use the columns attribute to access the new columns with results or the tails method to take a peek at the data frame, and after that we can continue with our post-processing. Some indicator arguments have been reordered for consistency. You can use the help method, for example help ta.indicatorName, for more information, or make a pull request to improve documentation. If you wanted to find information about TA, you can just do help and pass the df.ta attribute. You can list all indicators with df.ta.indicators method. And if you want help about an indicator such as Bollinger Bands or B-Bands, you can simply do help of ta.bbands. In terms of programming conventions, Pandas TA has three primary styles of processing: technical indicators for your use case and or requirements. They are data frame extension and the Pandas TA strategy, each with increasing levels of abstraction for ease of use. As you become more familiar with Pandas TA, the simplicity and speed of using a Pandas TA strategy may become more apparent. Furthermore, you can create your own indicators through chaining and composition. Lastly, each indicator either returns a series or a data frame in uppercase underscore format regardless of style. Let's go through each of the three styles of processing technical indicators. First, let's look at the standard style, where you explicitly define the input columns and take care of the output. So for example, if we wanted to calculate the simple moving average for a period of 10, we would call the SMA method on the TA variable. We would pass the close price column from the data frame and the parameter length with the value of 10. The returned series will have a name uppercase SMA underscore 10. In another example, if we wanted to calculate the Donchian indicator, we simply call the Donchian method on TA. We would pass the high column, the low column, the lower length parameter with a value of 10 and the upper length parameter with a value of 15, and this will return a data frame named dc underscore 10 underscore 15 and column names dcl underscore 10 underscore 15 and dcm underscore 10 underscore 15 and dcu underscore 10 underscore 15. To calculate the exponential moving average, we can call the EMA method on TA, to which we pass as a parameter the ta.ohlc4 method, to which we pass the open price column, the high price column, the low price column, and the close price column. Finally, the initial EMA method will also get the length parameter equal to 10. This showcases how we can chain indicators, and as you can see, we have to be explicit about the way we actually chain them. The series returned will be named EMA underscore 10. Because of this, there might be some additional confusion, and you may need to uniquely name it separately. The second style we're going to discuss is the Pandas TA data frame extension. Calling df.ta will automatically lowercase ohlcva to lowercase ohlcva. that is open, high, low, close, volume, and adjusted close. By default, df.ta will use OHLCVA for the indicator arguments, removing the need to specify input columns directly. Let's see a few examples. If we wanted to calculate the simple moving average for a period of 10 data points, we would simply call df.ta.sma. We would pass the parameter length equal to 10, and the returned series will have a name uppercase SMA underscore 10. For the EMA or exponential moving average indicator that we saw earlier for our previous style, we can now call the df.ta.ema method. We can pass the parameter close with the value df.ta.ohlc4, the length 10, and the suffix ohlc4. This will return a series with the name EMA10 ohlc4. Chaining indicators require specifying the input like close equal to df.ta.ohlc4. To calculate the Donchian indicator, we simply call df.ta.Donchian with the parameter lower underscore length equal to 10 and upper length equal to 15. This will return a data frame named dc underscore 10 underscore 15 and column names dcl underscore 10 underscore 15, dcm underscore 10 underscore 15, and dcu underscore 10 underscore 15. Same as the last three examples, but appending the results directly to the data frame df, we can simply call df.ta.sma, pass the length equals to 10, and the parameter append equals to true, which will append to df the column name sma underscore 10. We can call df.ta.ema, to which we pass the parameter close equals to df.ta.ohlc4 with the parameter append equal to true, and to the original EMA method we also pass the parameters length equal to 10, suffix equal to ohlc4, and append equal to true. Once again, chaining indicators require specifying the input like close equals to df.ta.ohlc4. And finally, for the Donchian indicator, we can calculate it as df.ta.Donchian, to which we pass lower length equal to 10, upper length equal to 15, and append equal to true. Appends to df with column names dcl underscore 10 underscore 15, dcm underscore 10 underscore 15, and dcu underscore 10 underscore 15. Finally, the last style we're going to talk about is the Pandas TA strategy. A Pandas TA strategy is a named group of indicators to be run by the strategy method. All strategies use multiprocessing except when using the call underscore names parameter. There are different types of strategies listed in the following section. In front of you, you have an example of how you would implement the previous styles that we saw using the strategy class. We can simply call ta.strategy, pass the name, in this case DC SMA10, and then the parameter ta, which is a list containing dictionaries. Each dictionary will have a kind key. The first will be having the value ohlc4, the second one will have the value SMA and will also have the key length with the value 10. The third one will have the kind key value Donchian, the value 10 for the lower length and the value 15 for the upper length. And finally, the last dictionary will have the kind EMA, the close OLHC4, the length 10, and the suffix OHLC4. We save this in the myStrategy variable. And finally, to run the strategy, we simply execute df.ta.strategy, to which we pass myStrategy. A strategy class is a simple way to name and group your favorite technical analysis indicators by using a data class. Pandas TA comes with two pre-built basic strategies to help you get started: all strategy and common strategy. A strategy can be as simple as the common strategy or as complex as needed using composition or chaining. When using the strategy method, all indicators will be automatically appended to the data frame df. You are using a chain strategy when you have the output of one indicator as input into one or more indicators in the same strategy. Note, use the prefix and or the suffix keywords to distinguish the composed indicator from its default series. You can check the Pandas TA strategy examples notebook for examples including indicator composition and chaining. In terms of strategy requirements, you'll have the name, which is some short memorable thing, as long as it's not the case insensitive all keyword, which is already reserved. Another strategy requirement is TA, which is a list of dictionaries containing keyword arguments to identify the indicator, and the indicator's arguments. A strategy will fall when consumed by Pandas TA if there is no kind attribute with an indicator name. There are also some optional parameters. Description, which is a more detailed description of what the strategy tries to capture, which by default is none. And also another optional parameter is created, which is a datetime string of when it was created. By default, it's automatically generated. Let's look at a few types of strategies. Built-in. Running the built-in common strategy as mentioned above. You can simply run df.ta.strategy and pass the ta.commonStrategy parameter. The default strategy is the ta.allStrategy. The following lines of code are equivalent. df.ta.strategy, to which we pass the string all as a parameter, and df.ta.strategy, to which we pass ta.allStrategy as a parameter. Another type of strategy is categorical. If we want to list the indicator categories, we simply call df.ta.categories. Running a categorical strategy only requires the category name. df.ta.strategy momentum, which yields the default values for all momentum indicators. df.ta.strategy overlap, length equals to 42, which overrides all overlap length attributes. To create a custom strategy, we simply call ta.strategy, pass the name, the description, and then the TA list with all the dictionaries that will have a kind key. Some of them might have a length key, such as SMA for simple moving average and B bands for Bollinger Bands. Others like MACD might have the fast and slow keys for the two moving averages that are used when calculating the indicator. And finally, you can also pass keys such as close to specify which column is used when applying the indicator. In the last dictionary, we're calculating the simple moving average on the volume column. To run the custom strategy, we simply call df.ta.strategy and then we pass our custom strategy. The Pandas TA strategy method utilizes multiprocessing for bulk indicator processing of all strategy types, with one exception: when using the call_names parameter to rename resultant columns. The indicators in TA array will be run in order. We first use the setIndex method to replace datetime with the appropriate column from the data frame and ensure that the data frame index is a datetime index. Then we run and append all indicators to the current data frame by default with df.ta.strategy, or using df.ta.strategy, to which we pass the string all, or df.ta.strategy, to which we pass ta.allStrategy. The verbose parameter can be used if you want to make sure the strategy is running, and the timed attribute if you want to see how long it takes to run. You can choose the number of cores leveraged during the processing by setting the df.ta.cores attribute. If you do not want certain indicators, just exclude a list of them with the exclude parameter. If you need to use different values for certain indicators, you can pass them as parameters for the strategy method, such as df.ta.strategy, to which we pass the fast and slow parameters. You can always access the columns attribute of the data frame to check if all columns are present. As mentioned before, whenever you use the call name key within your custom strategy, the library won't be able to use multiprocessing. Therefore, you have to be aware of this limitation. In this example, we are using call_names for the B band and the MACD indicators. Pandas TA data frames have several properties that we have to be aware of. The adjusted attribute, it's used to set TA to default to an adjusted column, adjusted_close, overriding the default close. One example of using it would be df.ta.adjusted equal to adjusted_close. Then we can run our indicator for a simple moving average, df.ta.sma, to which we pass the length 10 and append equal true. We can also reset back to close by setting the adjusted property back to none. Another property we should be aware of is categories, which is simply used to list the Pandas TA categories. We can call it as df.ta.categories. The cores property, it's used to set the number of cores to use for strategy multiprocessing. It defaults to the number of CPUs you have. df.ta.cores equals to 4. You can set the number of cores to 0 for no multiprocessing. df.ta.cores equals 0. df.ta.cores returns the number of cores you set or your default number of CPUs. For df.ta.datetime ordered, the datetime order property returns true if if the data frame index is of pandas datetime64 type and df.index0 is lower than df.index-1. Otherwise, it returns false. The df.ta.exchange sets the exchange to use when calculating the last run price. By default, it's NYSE, the New York Stock Exchange. You can also set the df.ta.exchange to another exchange. For example, LSE. Other options available include ASX, BMF, JSE, and so on. The df.ta.lastRun returns the time pandas.ta was last run as a string. The df.ta.reverse is a helper property that returns the data frame in reverse order. Regarding prefixes and suffixes, to apply a prefix to the name of an indicator, we can simply use the prefix equal pre parameter. For suffix, we can use the suffix equal post parameter. We can also combine them together. For example, df.ta.hl2, to which we pass the prefix pre and the suffix post, and we'll obtain the column name pre_hl2_post. The time range property returns the time range of the data frame as a float. By default, it returns the time in years. Available time ranges include years, months, weeks, days, hours, and minutes. We can simply set the time range to days by running df.ta.time_range equals to days. Finally, df.ta.toUTC sets the data frame index to UTC format. Pandas.ta data frames also come with some methods. The constants method can be used to add or remove constants to the data frame. Constants can be quite useful for charting purposes. The indicators method can be used to print the indicators and the utility functions. They can also be returned as a list if you pass the asList parameter equal to true. Print. You can also exclude certain indicators from being printed or returned by passing the exclude parameter with a list containing the names of the indicators you want to exclude. You can also combine the exclude and the asList parameters in a single function call. Finally, the ticker method can be used to download chart history using yfinance if you install it using pip install yfinance. It uses the same keyword arguments as yfinance. If you wanted to get the data for Apple, for example, which has the ticker AAPL, we simply call df.ta.ticker and pass the parameter string AAPL. The period is used instead of the start and end parameters from yfinance. Valid periods include 1 day, 5 days, 1 month, 3 months, 6 months, 1 year, 2 years, 5 years, 10 years, year to date, and max. The default value for the period is max, which is the maximum amount of data available for that ticker. We can change the period to only get the data from the past year by setting period equal to 1y as a string. History by interval, including intraday, if the period is shorter than 60 days. Valid intervals include 1 minute, 2 minutes, 5 minutes, 15 minutes, 30 minutes, 60 minutes, 90 minutes, 1 hour, 1 day, 5 days, 1 week, 1 month, 3 months, and by default it's set to 1 day. We can combine the period and the interval parameters. So for example, we can pass period equal to 1 year and interval equal to 1 week. So we can get the data from the past year in weeks. We can also set the period to 1 month and the interval to 1 hour, which means we can get the data from the past month in hourly intervals. You can call the help function on the ta.yf to learn more about its function. In the indicator section in the documentation, you can check which indicators are available by category. There is also a list of available metrics within Pandas.ta, such as compounded annual growth rate, CAGR, Kalmar ratio, downside deviation, Jensen's alpha, log max drawdown, pure profit score, Sharpe ratio, Sortino ratio, and volatility. Pandas.ta is also well integrated with VectorBT. VectorBT is a Python package for quantitative analysis that operates entirely on pandas and NumPy objects and is accelerated by Numba to analyze data at speed and scale. For easier integration with VectorBT's portfolio from signals method, the ta.trend_return method has been replaced with ta.tSignals method to simplify the generation of trading signals. For a comprehensive example, you can check the example notebook provided in the Pandas.ta GitHub repo. We can see an example of how to use VectorBT together with Pandas.ta. We first download the data for Apple, ticker AAPL. We then create the so-called golden cross trading signal, which happens happens whenever the 50-day moving average crosses above the 200-day moving average. Then we use the TS signals method to create the Boolean trading signals for vector BT. Then we create the signals portfolio by simply calling vector BT.portfolio.fromSignals, passing the closing price, passing the entries parameter, which in this case would be our golden trading signal TS entries, and the exits parameter, which will be golden.TS exits, as well as the frequency, which would be daily, the initial amount of cash, which would be 100,000, the fees, which would be 0.0025, and the slippage, 0.0025. Finally, we can print the statistics and the return statistics. If you've enjoyed this video so far, it will really help me a lot if you subscribe to my channel by clicking the subscribe button and hitting the notification bell. I know most of you are not subscribed already, so you might miss out on any future content that I will release on this channel. Please subscribe today. Thank you. I recently created a Patreon account for the data science channel. At the moment, I create my videos in my spare time while also working a full-time job. Having a Patreon would allow me to receive donations from people like you who have enjoyed the videos that I've produced so far, and will help me improve the quality and the frequency of the videos that I post on the channel. Moreover, for each of the membership options available, I will provide some extra services for those of you who decide to support me.